I'm excited to be here because I like interacting with young people. So, in particular, today's topic will be going to be a little bit boring, perhaps, because I gave a list of 5 things for people of 5 or 4 items for you to pick what to talk about. But this apparently was a popular choice. So, but this is quite non-technical, so you won't see any equations. So if you're, might get disappointed, those of you who are mathematically inclined. So I'm going to talk about mathematics and its quote unquote unreasonable effectiveness. I'm quoting mathematical physicist of the 20th century, Eugene Wigner, who has a book on unreasonable effectiveness of mathematics in the physical sciences. So that's the quote: unreasonable effectiveness in the sciences and the potential role in tomorrow's Bangladesh. All right. The impact of mathematics and its appearance in different guises. I'm just outlining the points I'll make. Then I'll talk a little bit about the nature of mathematics and its connection with other sciences. As you'll see, mathematics has a very different starting point. It starts with axioms and then you arrive at theorems, and then things follow. Whereas in the other sciences, it's a constant interplay between what you observe and you theorize, and then you correct your hypothesis until observations agree with what is predicted in theory. So mathematics and the sciences are very different origin. So therefore, it is a little bit of mystery. Why is it that mathematics become intrinsically so useful in the sciences? That's one of the topics I'll talk about. And then I'll talk a little bit about things that concern Bangladesh. I'll start off with how mathematics is an economic accelerator by giving evidence of what happened, for instance, in Britain. Then I'll talk about the situation in Bangladesh as I perceive it, and I have been in touch with educators here, including in your university. So talk about challenges and promises, and a little bit of my ideas of what could be done at different levels before I conclude my talk. So the first item is impact of mathematics in modern society, and I think for most of the things I'm going to talk about is not foreign to you. Every area of science and engineering, as you know, and increasingly in the social sciences, mathematics is being used. Anytime you go beyond qualitative to quantitative understanding, you say something is hotter than another thing, but as soon as you want to say how hot and how cold, then you have to rely on numbers, right? So that's where mathematics comes in a very basic level. Mathematics is also at the basis of algorithms used in modern computers. And if you think about it, if then else, these are all logical arguments. And the basis for mathematics is logic. Yeah. So it's not quite unreasonable to think that the mathematical way of thinking becomes so relevant in other areas, such as computer science. So it's the basis of algorithms used in modern computers, mobile phones, machine learning, and artificial intelligence. Though a user probably doesn't know what the mathematics is, because it's under the hood. Encryption for secure financial transaction, all right? Like you want to make sure, or you have a website, you want it to be a secure one, then these involve encryption. And encryption relies, one of the algorithms on encryption relies on factorization of large prime numbers, huge large. And then there is an associated mathematical problem, which is very important, whether so-called P is equal to NP. I don't go into that. And that has quite a bit of relevance in this department. And also, if you develop quantum algorithms, you might actually have the bad news of your banks getting hacked, and one has to then look for new kind of algorithms to secure your bank transactions. So all these things I'm saying have very much relevance in the modern world. In medical imaging, such as CAT scans, one uses something called radon transform. This is part of harmonic analysis, which is part of mathematics. Though if you are sitting in the getting your CT scan done, you are not thinking about the mathematics that goes behind, that underlies these applications. In that sense, many of these things, they are under the hood. The examples here are mostly, in more advanced applications. And you might think, how does that relate to a country like Bangladesh, where we don't really need to know all these things? We can be just end users. Well, the next few applications show that that's not necessarily the case. If you want to do accurate weather modeling or climate modeling, you have a set of complex partial differential equations that you need to solve. Epidemic modeling is another good example where you need a lot of mathematics. Very practical problems, like you're running a service industry and you're trying to figure out how many people to put in each of the desks, right? It's an apportionment problem. So this is part of what is called queuing theory, which is part of probability theory, which is part of mathematics, all right? So security of online systems I already mentioned, and whether or not, if you don't want to know anything about what goes on, you basically have to have some idea what's behind this, encryption. Why? Because you might have malicious actors. You have to know the capabilities of those actors, and in what sense can your system be not so secure, right? So that requires a little bit of the understanding of the algorithms that go behind it. So effective measures to remove bottlenecks in traffic, Dhaka traffic, I don't have to say much about it. Some of you are late over here because of the Dhaka traffic. And that, how you actually remove effectively bottlenecks, that requires a little bit of modeling. And I'm sure traffic engineering people, they know this is an engineering problem, but there is mathematics behind it. Then effective lifetime prediction of arsenic filters. I was in Oxford. They invited me to give a talk, and I met a colleague there a couple of years back, and he showed me his model of getting how you actually look at the arsenic filter and try to find out what is the effective lifetime. Yeah, and that's a very useful thing, because you don't want people to start suffering before you realize that your filter is not working anymore, correct? So these are and there's a YouTube link there you could watch where this modeling has been done. Now, computer appears in many different guises, and most people in Bangladesh, even educated people, even policymakers, even vice chancellors, they have no idea how widespread mathematics is. And more generally, I'm defining all kinds of mathematical sciences under one umbrella. And they don't have any idea. But if you look through history, one of the pioneers of computer science is a mathematician, Alan Turing, very well known for breaking the Enigma code of the Nazi Germany. Alan Turing was a logician at Cambridge. Nash equilibrium theory. John Nash, you may have seen that movie, he lost his mind for a while, The Beautiful Mind. Many of you have seen that movie, right? So John Nash, during his PhD thesis, he talked about, he invented the idea of Nash equilibrium, and which was a bit counterintuitive. And it uses basically linear algebra, probability theory, and functional analysis. It's basically a fixed point theorem, which is part of functional analysis. That's the work is. Many years later, when people came over to give him to say that you're being nominated for Nobel Prize, he was a bit surprised because he said, wow, that's just, I've done much better things, better for him and much more mathematical, abstract things. And that was just his PhD thesis. But it just turned out that that was a landmark contribution in economics, right? So he got the Nobel Prize in economics for that. But Nash equilibrium is a big deal in economics, right? Einstein's general theory of relativity, Einstein had to learn Riemannian geometry, which is from Bernard Riemann, before he could actually quantify his ideas in general relativity. Whether it's Big Bang Theory, some of you in this audience are not unfamiliar with what I'm saying. Quantum computers, computational chemistry, robotics or AI all have advanced mathematics at its very heart. Yeah. The same is true for most areas of engineering, and mathematics is also gaining increasing currency in the social sciences. You could think of a game theoretic modeling of given a particular country, particular political situation, and particular history, given this condition, what are the possible outcomes? Right? This is a game theoretic calculations. And there are organizations in the US which actually does that, game theoretic calculations, and figures out what are the probabilities of different sort of outcome. I'm not sure if people, Bangladeshi economists, are doing any kind of that, but this is useful in the sense that if you look through these simulations, you could actually figure out what are the critical points where a little bit of push in one direction or the other could give you very different outcomes. Okay? So anyway, I went a little bit more than I wanted to say, but mathematics also provides an overarching principle that combines seemingly disparate kind of sciences all under the same umbrella. Some of you probably already know this. So let's consider, for instance, the oscillations. Oscillations occur in many problems. You have pendulum, yeah? In high school physics, you do pendulum experiment. You have LCR, electrical circuits, yeah? The LCR's electrical circuit, you have oscillations. And if you're doing physics experiment, that's one of the first things you do, maybe first, second year. And then you have earthquakes, you have beams, you have water waves, and I can keep going. They all have the same common mathematical framework, in a generalized sense. They're not all the exact same equations, but have a common mathematical framework where you work with dynamics of oscillations. And these are dynamical systems, and you look at, there is a very specific kind of mathematics that are being used in those areas. Mathematics of control theory, all right? So you imagine you have a robot, all right? Robot, what does a robot do? It takes the arm goes like this, all right? So that's a rotation matrix, yeah, involved in that. then it's translation. So through a combination of rotation and translation, a robot goes from one position to another. And you might want to introduce some constraints so it doesn't hit the wall, all right? So, but essentially, that's robotic motion involves lots of linear algebra, correct? But where's the control coming from? I mean, what you want this motion, you want to minimize the cost function, which would be the energy for the robot uses, correct? So you have these variables. How should the motion occur, right? In what way should you do that so that you have the most efficient way? So there is a mathematics involved there. But that mathematics involved in robotics or in satellite orbits, satellite goes all over, and then satellite. What does the satellite do? Satellite, when it's going. Let's think of a geocentric or orbit satellite, which means what? Which means that it is at a particular height, about 25,000 miles from the center of the Earth, where just the centripetal force is provided by gravity, and then at any particular position on the Earth, you look up, the satellite is stationary, correct? So those satellites are used. That's where you get your TV channels, all right? So but the satellites, when they're going around, they cannot. They have to maintain their particular location. Well, sometimes they don't. They want to come down, they're going to go up. So what do they do? They send a little bit of a signal down to the Earth, and it reflects back. And by measuring the distance, that's how they measured how far you up the position is, just by reflecting, getting the reflection from the Earth. And then when it is not at the desired height, you push a little rocket, right? So it maintains the height. So that's a control system. The mathematics of control system and the mathematics of in artificial intelligence, one uses neural network. The mathematics is not also that dissimilar, because in neural network, what do? You have a set of inputs and maybe a set of outputs. You go through layers, and then you have these unknowns, which are the weights and which are the biases, and you figure out weights and biases until you get your desired output. And when you've done that, you say the machine has learned, right? That's what we're using for machine learning. So that idea of minimizing the cost function, that's similar to what you're doing in control theory in a generalized sense. The principle of least action in physics, you work out a Lagrangian, and many of you are in the physics department, so you know a little bit of that. You work out the Lagrangian, you invoke the principle of least action, and then what do? You actually minimize it, right? But then this is variational calculus, right? Variational calculus. Well, that's also used in finite element methods when you are actually doing an engineering field. You're using the same kind of mathematics. Diffusion process of all kinds. There is diffusion of mass, diffusion of chemical. These involve the same kind of mathematics. So you see, mathematics combines seemingly disparate areas under this, and it gives them the same umbrella, right? All right. So now, here is an example of neural network. I will just show you here the inputs and outputs that I talk about, but this is supposed to be a non-technical talk, but this is the only picture I'll show. Those of you, if you keep asking me more, I'll probably get stuck at some point, because I don't know too much about it. Mathematics, now I talk a little bit about the nature of mathematics, right? And how it differs from other sciences. Mathematics is not just about adding and subtracting numbers or mastering rules. This is the layman conception of math. You add numbers, okay, x plus 5 is 7. Take the plus 5 to the other side, it becomes minus 5 mysteriously, all right? So you x equal to 7 minus 5 is equal to 2. That's how you. Why should you take it to the other side? Why should the plus 5 become minus 5? Why? Nobody asks, nobody, this is the rule. So when you're taught that way, you take it all as rules, and all mathematics is just applying the rules. Somebody gave you those rules. But in essence, mathematics is not just about mastering rules or adding and subtracting numbers. In its purest form, mathematics is at the pinnacle of human logical thinking process, right? You start with some basic self-contradicting axioms, and everything else follows. That's the nature of mathematics. This differs from other sciences because, as I mentioned before, in the other sciences, you look at you have an observation, you look at a phenomena, you theorize what might be going on. That's called hypotheses. Then you then try to predict something, and then you go back to the observation. Doesn't match, you go back to drawing board, rework your hypothesis until you get agreement between experiment and theory. That's how the other sciences progress. Either observation in the case of astronomy, or in the case of basic things, you do experiment. So that's how the other sciences progress, whereas in mathematics, it all starts from a logical framework, and then everything else follows. So the natural question is, why in the world should mathematics be so naturally useful? Well, there is a reason for that. In principle, there is no, you see, we have a unity in the sciences. What is that? We only have very few basic laws of the physical universe. And Einstein worked for the last 40 years to try to find a unified theory, right? So at its core, there are only a few laws. But if you think about it, there is no a priori reason why the universe should be that way. You could always think of a universe where each interaction between particles, between water and vapor, and every interaction has its own law, correct? You could have in that case, in that world, mathematics would not be that useful. I'll explain in a second why I say that. But in reality, we observe that there is a huge simplification in the physical universe. There are only few basic laws. Everything else are derived laws. For instance, you put together Newton's law of motion and Newton's law of gravitation, and Kepler's law of planetary motion follows just from calculus, right? Just putting those two things, you can derive Kepler's law of planetary motion. Similarly, there are a lot of things that you can, if you look at, so thermodynamics is basically coming from statistical physics, right? So that's also, so these are derived laws, right? Yeah. So in a sense, since there are few fundamental laws and the consequences of those fundamental laws are given in terms of mathematics, because once you quantify, you put numbers. All other laws follow as consequence, just like theorems and corollaries follow from axioms. Yeah. So you have a few fundamental laws. All the other physical consequences are following as mathematical theorems and corollaries. of those physical laws. All right? And this is the fundamental reason why mathematics becomes so unusually useful and reasonably effective. You can understand in a very basic way how, this is a very trivial example. You take two sticks, all right? You put them together, it has a certain length, right? Well, the nature of the universe is that these two sticks, if I watch them this way, the length doesn't change, right? So 3 plus 4 is 4 plus 3, right? Well, that's reflected in the arithmetic we do. We have A plus B is B plus A, correct? So you see, this is a natural reflection of the mathematical law. Similarly, lengths are invariant under rotation, correct? But this is reflected in the properties of rotation matrix. Yeah. In quantum mechanics, there is such a unitary operator and things like that, but let me not go into more complicated examples. Now let's talk about Bangladesh and how mathematics is more generally useful, or how can it be more generally. So I start off the example. There is a report by Deloitte that was pointed out to me by colleagues in Britain, which estimated that the net impact of mathematical activities of all forms to British economy was $300 billion a year. This is just one year, and it accounted for 10% of all new jobs. Well, the report link is given there. So this is not in, this is where you can see. Technology is a prime driver of East Asian economies. We all know that. And technical prowess of workforce is very important. And mathematics is a big part of that picture, right? It's an essential component. It's not just you have to do math to get there. It's a mathematical thinking. It's the idea that you go from one point to another, point A to point B, through a sequence of logical steps. So you may not know that by learning this, you are actually using mathematical thinking, which is then useful in any other areas of human endeavor, because you're thinking methodically and carefully, right? Now, the other thing is, as a country's wages rise, then you essentially cannot rely on low skill and low wage economy, right? Because you get up because somebody else, maybe some African country, steals your bread, all right? Because they can do it for even less wage. So you cannot expect to have a low wage, low skill economy going farther. So you need to grow your force and more technically adapt workforce. So now, what are the challenges for Bangladesh if you want to go in the way I indicated? Well, we have these three challenges that in my opinion. One is, of course, learning and dissemination problems. That's a huge problem. I could talk forever on that. The other problem is the talent pool problem. Talent pool meaning the talent of people entering this profession. Now, that's not only affecting mathematics, that's affecting everyone who consumes mathematics, right? Because if you have people in engineering who did not quite have a good mathematical training, then when they go get a PhD or some higher degree, then some areas of engineering which are much more mathematical, like signal processing, all right, or control theory, or some, or even robotics. Some areas are completely out. They can't do research in those areas, right? So you're shortchanging their career by not having a good enough mathematical background, because the teachers that you have, I'm not talking about this place, but in general, the teachers are that we don't have sufficiently, high level people who can actually recognize that what they're teaching, how it is connected to everything else. So that lack of mathematical talent is a big factor, as far as I can see, in Bangladesh. There is also, what contributes to that is a widespread misperception about scope and usefulness of mathematics. ম্যাথ পড়ে কি হবে, মাস্টার হবা নাহলে কি হবে? আর entering Dhaka University math পড়ে, you don't even want to study math, but you are pushed into it because you have this weird admission system where you don't necessarily, but that's the option you're given. So your aim in life is go to the math department and then somehow get a degree and hopefully get into BCS, and you are set for life. All right. But this is no way of inculcating a math core, discipline because if you have those students in your class and you're trying to teach somebody maybe a little bit of proof in linear algebra, তারপরে আন্দোলন করে তোমাকে খেয়ে দিয়ে দেবে. And this is, I'm not joking. This is one of the Bangladeshi students who actually went and worked with me. He said, how come you didn't learn this? He said, oh, yeah, one of our teachers tried to explain. আমরা আন্দোলন করে ওনাকে সরিয়ে দিয়েছি because আমরা বুঝতে পারিনি. So, but if you have a class which is not quite that interested in learning mathematics, just wants to get a degree somehow so that they can move on, then this is what's going to happen. So anyway, let me touch on each of the topics. Learning and dissemination problem. There are too many subjects at the lower level. Little kids carrying books which may weigh them down, all right? Too many subjects at too early stage. Little kids are supposed to play around. That's a way of learning, you can't put so many subjects and you crowd out the schedule. So when you crowd out the schedule, what happens? Kids look for shortcut. And what is the most common shortcut? Memorization. Yeah? বুঝলাম না, আচ্ছা মুখস্থ করে ফেলি, the common পরীক্ষা আসবে, there will be some common exams. Yeah, I study for common things, and then I get lucky. And if the teacher doesn't get, if there are no common exams, আমি আন্দোলন করা শুরু করি. So this has become the problem. There's also too much emphasis on learning facts. Too much emphasis on learning facts, not on reasoning skills. Yeah? All of you probably have a little bit of this in your background to appreciate what I'm saying. There is little diversity in exams. I already mentioned that, and a very low bar of GPA 5. Again, a Bangladeshi student who worked with me told me, I asked him, proof এগুলো দেখো নাই? হাই স্কুলে তো দেখেছো জিওমেট্রিতে প্রুফ। বলে না স্যার, আমরা জিপিএ 5 পাইতে ওই কিছু প্রুফ স্কিপ করলেও অসুবিধা নাই। So we have, if you don't inculcate this idea of you have to think through logically and you have to study material, and you see no reward to it because you have to maintain your GPA 5. I tell you a story of GPA 5. There was a student in Cambridge who got a full scholarship, and I met him when I was there. And he told me he wasn't really, he was worried that he wouldn't get into Dhaka University because he didn't have a GPA 5, because he had too much. I think his name was Asif Elahi, or was he at Cambridge? Yeah. I think I met him. So I said, I was worried. Did he go to Sylhet Pilot School or something? Yeah. So yeah, he's the guy. So he said, I was worried that I didn't have because he was put too much of his, emphasis on math. And so he had some not less than a perfect GPA. So I thought to myself, he's good enough to get a scholarship at Cambridge, but not good enough to get into Dhaka University. What kind of absurd situation is it? So there is also, exams in entrance exams is a perfect example in the admission system in the public universities. I'm glad that some of the Shah Jalal University, for instance, they take in students who have done well in the Olympiads automatically, which is a good idea. The exams, including university exams, reward speed rather than depth. And this is a real problem. There are also not too many incentives for teachers to teach beyond exam material. There is the other problem. I always, you have a record number of students trying to get into elite universities like Dhaka University and, some of the better universities even. But the outcome is what I see, when people applying to graduate schools and things like that. That's the outcome I'm seeing. And then the outcome should be much better, right? Because আমরা যখন লেখাপড়া করেছি, when I joined Dhaka University Physics Department in 1974, ancient times for you, then we didn't have as much competition, all right? So your generation should be much, much better because there is like 100 times or 1,000 times more competition. But I don't see that in what we are seeing. So I ask myself, why is it that despite this record, part of the reason is 50 years back, the best students in my graduating, we had marks, and then you had top 10 students in the board. Among the top 10 in Dhaka board, among the top 10, except for the 10th person, not a single one went to engineering or medical science. All of them went to either economics, physics, chemistry. And so in basic sciences, there was a lot of people, physics was particularly had a big, but it changed within a couple of years. So the people who are the people entering the basic sciences are relative to their peers, they're a bit weaker. And we also have the problem of what you're doing. It's not just the product that are coming in, it's how you nurture them and what ends up. And that is also a huge problem. So also the mathematics is not considered an attractive career option, and undervaluing mathematics impacts its demand and worsens the talent problem. And when you have a talent problem, you're also affecting the careers of economists trained in Bangladesh or engineers, because they can't be experts in certain things. Even computer scientists, if you don't teach enough number theory and things like that, and you want them to work in cryptography, and they will struggle. in some areas, if you want to make big advances, you will struggle. So the misperception about value of mathematics, I already mentioned that. Most people in Bangladesh think that it's mere mastery of rules and application. And unrecognized is that reasoning from point A to point B, as I mentioned, is an important skill. Yeah. And this skill goes beyond mathematics. And this is unrecognized in Bangladesh, but not so where I am in the US. How do I know that? Well, I know it in a number of ways. One thing is the number of undergraduate majors has most recent years is gone down a little bit after post-COVID, but we had a surge of numbers from starting when I joined. It was more like 200 math majors in the department, went up to 1,200, right? And then it gone down recently about 800 and 900 because of COVID situation, things like that. And I wondered, most of them are not pursuing math as a career. Part of the reason they're doing math is because graduate schools, even in business, even medical school, even law school, they prefer students, they don't, MBA programs do not necessarily like BBA students, right? They like applicants from coming from backgrounds, quote unquote, with hard sciences, physics and math and that kind of background. So as a result, our students find it easy to go into graduate school, some of them even law school, business schools, and some of them with a little bit of biology courses, some of them get into medical school, right? So that gives them an attractive career option. And many of our students end up, graduate students end up in Wall Street because there's financial mathematics that is used in Wall Street. And some of them end up in banks and other industries, whereas there is no such recognition among Bangladeshi employers that math could actually be useful to them, all right? So that's part of this. Part of it may be that the math students that are trained here are not as effective communicators, and they should have. I don't know if you have it over here, courses in English and other things when you actually and also have presentations made so that you're better at communicating with people. So that is a problem, and I already mentioned about Western employers. So what are the promises? I see, of course, the shining example of Bangladesh Math International Olympiad. This is a real shining example under the very able leadership of Mahabub Mojumdar. That is a shining example, and I suppose they changed the format, and the Bangladeshi students were not doing as well because the geometry is taken away from them. But nonetheless, it's quite very respectable relative to other countries, it fluctuates between 26 and 45, something like that, out of the more than 100 in some countries. That's quite respectable. And so what that shows is there are enough kids who would actually be trained to do much better than what we are seeing, right? We simply need a culture here. And so that's a one good example. At Brack University, I'm also glad I actually watched a little bit of inflation talk by one of your colleagues or a young, maybe PhD student. So that was quite very impressive. So locally, you have grown a culture where you are valuing research and you're trying to learn from each other. The other factor, which I did not address here, but anyway, I'm talking about promises. So these successes that I'm seeing locally. There is no reason why it can be much more spread out at many different institutions. Yeah, because there is no good reason, except for the fact that in public universities, you get people entering math department who have no interest in math. So that's a separate issue, and that has to do with this ridiculous admission procedure that someone came up with, and I don't know why they are not thinking of changing it. So what can be done? Well, one way is extensive resource sharing from institutions home and abroad, and it can add value to a student degree. Yeah? In what way? If you actually do some work and you have a foreign collaborator, yeah, you start doing some research, then after you get out, you have a way, somebody else vouching for you. Yeah, you're coming from Bangladesh, so there is usually a negative feeling that, oh, I don't know what they are taught. But if someone else from some other institution abroad, either in the West or even in China or Japan, they actually say something about you, then it strengthens your case. And in fact, I know it firsthand because we have a student from Lebanon who applied, and he had someone from an American university who had glowing things to say about him. So even though there was not too much information on that particular university, we took him in. So the other, so this also, there's also, we need a cooperative mode. There are many programs which are kind of small. They have disjointed 2 or 3 year math faculty. They're just teaching. They may have done PhD at some point, but they don't have a community. You need a community, really, to actually get a culture, right? So one way you could do that is actually form between universities cooperation agreement, right? Where you actually share each other's resource. Mathematicians and consumers of mathematics have to be better coordinated, you know, because sometimes people doing traffic engineering, they don't quite understand that there are next door, maybe 2 doors down, there is someone who is an expert on nonlinear waves who could actually help them with some of the traffic modeling problems, all right? Or somebody in numerical analysis could help in a finite element problem, yeah, find a better basis. Or somebody in image processing could be helped by someone who knows a little bit of harmonic analysis and knows about multi-resolution analysis. So that thing is not quite, so this is what you get by having cooperation between different people. Double major in allied areas, yeah, that's another way of actually rejuvenating the connection between math and consumers of math. A center of mathematical science that brings together top mathematical scientists and consumers. That's another way that would be actually quite a useful step, but that would require resources. University entrance exams, as I mentioned before, should be more about depth than speed. Well-performing, I already mentioned that. Avoid repeat exams, repeat problems in exams year after year. And to avoid having this problem of andolan, all right? There is a way of going. Andolan is really about expectation. If you have a whole generation of kids growing up memorizing, all right? And then all of a sudden you give them something very uncomfortable. Yeah? So you're putting them up in the deep water. They don't know what to do. So the best they want to be a way out from that situation. So that's how. So all the that you try to in the past they've tried to change the education policy very quickly, very suddenly, and the whole the teachers are not ready, the students are not ready. You can't do it overnight. You have to do it slowly. You have to have a target. This is where I want to go. This is how I'm going to accomplish. Year by year, we'll have fewer and fewer common exams type. So you get a whole generation used to higher expectations slowly and gradually. Yeah? Because whatever solution you want to say, it has to be workable, correct? So that's a thought about how to change curriculum. And the curriculum has to be much more about basics. At early level, do not flood them with that many subjects because you're destroying their neuron capacity by making them just memorize, all right? A good university, as I mentioned, must have a good department, and the financially well-endowed people who have a vision. We have a Tata Institute of Fundamental Research. 1947, India was not very rich, right? In Bangladesh, we are better off than that. How come our rich people do not have the vision to see how to same vision as Tata? Huh? There's Tata Institute of Fundamental Research, which still stands out as a outstanding institution. We need something like that. We also need, I mean, you'd say, oh, well, let have the government do this. But we have all this political government since our independence. None of our politicians had the sagacity not to appoint their favorite loyalist as the director to one of these institutes or one of these universities. So that's not the way to go. So from private funding, if something could be done by someone who understands how things are related and how things can grow, that would be a great thing. We also need a stronger nationwide teacher training program. Okay, just imagine this kind of future in Bangladesh. So you have assessment of outcome based on different courses of action using game theoretic models, using AI to sift through hundreds of thousands of citizens' complaints, all right? To figure out a pattern, then get to the source of the problem. Think how great that would be for administrators, right? Think of you have home-built robots, yeah, that carry out dangerous mission. You have some kind of fire or something like that. Yeah, the robot goes around and figures out, rescues people. That would be great. Suppose you had quantum computers which can carry out Monte Carlo kind of simulation and figure out higher molecular dimensional, modeling, and to allow calculate what is called activity coefficient of drugs very quickly, yeah, and you get drug discoveries. Think of innovative, clever algorithms for big advances. You don't have to rebuild everything. This guys in China, the DeepSeek. Have you heard of DeepSeek? They use basically ChatGPT, all right? And they use the new innovation. And then they got some great results, all right? There is no reason why Bangladesh is sitting here and perhaps in this audience. If you are sufficiently inventive, there's no reason why you can't do it. And you can't be a player in the world market. So all these potentials can be realized if you have a technically sophisticated. So technical sophistication goes at different levels. You could be sophisticated as a user. You could be informed about the use. You could also be at a very fundamental level, know about how things work. so that you can actually make a big advance, like the example I mentioned about what happened in China. So I'm probably going way too much. I already took up a lot of time, so here's the conclusion. Mathematics is at the heart of all areas of physical science and engineering, as well as some areas of social science. Proper mathematics dissemination requires critical level of talent entering the profession. Mathematics is important for skill upgrade as Bangladesh graduates from a low skill, low wage economy. Mathematics training cannot be just about learning and memorizing rules. There must be much more exposure to the logical aspect of the subject. Universities can seek to strengthen quantitative background of its student through cooperative arrangement with other universities at home and abroad, and directed use of online resources. Yeah. There could be actually greater integration between mathematics and allied subjects, and that is very desirable. And we have a few examples of successes in Bangladesh itself. One has to have conditions for replication created in order to have a multiplier effect. This needs the creation of an independent mathematical science institute. Thank you.